Welcome to Lesson 4. In this lesson, I will discuss all the available data types in Solidity language. First, I will look at the value types, and they are called value types because the variables of these types are always passed by value, meaning that they are always copied when they are used as function arguments or in assignments. The first, most basic value type is booleans. The possible values for a boolean are true and false, like in any programming language, and you simply declare it by typing bool, then the variable name, and then equals either true or false. Another really common data type is integers, which are declared by using keywords int and uint. Int stands for signed integer, where 255 bits are used to represent the value and 1 bit is used to denote the sign. Uint stands for unsigned integer, where all 256 bits are used to represent the value. Keywords uint and int go up in increments of 8, from the lowest value of 8 to the maximum value of 256. For example, int 8, int 16, uint 16, etc. uint and int by default are aliases for uint 256 and int 256 respectively. Now let's have a look at a short example of how integers behave. Let's copy this code and go to remix.ethereum.org. Paste the code. You can see I have already done that before. And let's explore what it does. As you can see, there are three functions: getFooBar, getMaxUint, and getMaxInt. GetFooBar simply adds up two integer numbers, 42 and 50, and returns them. Let's compile the contract again by clicking on Create and click here, getFooBar, and execute the function, and we get the answer 92. These two functions, getMaxUint and getMaxInt, are nothing special. They just declare the highest possible numbers for an unsigned integer here and a signed integer here. We don't really have to know the highest values, it's just for fun. You can see that the highest value for an unsigned integer is a lot larger than for a signed integer. Also, I'm showing you this just to show that it's possible to declare integer values by using hexadecimal notation rather than just typing, let's say, 255. Sometimes it's more convenient, but you don't have to use it. Now, let's have a look at another data type, fixed point numbers. Fixed point numbers are denoted by keywords fixed and uFixed. Fix stands for signed fixed point number and uFix stands for unsigned fixed point number. However, keep in mind that fixed point numbers are not fully supported yet by Solidity. They can be declared but cannot be assigned to or from. I am only showing you this so that you are aware that fixed point numbers are coming to Solidity and that you can declare them but you cannot use them yet. So, if you want to use float type division in Solidity, different size units have to be used. Bytes is another familiar data type which can be used to store raw byte data. Bytes is essentially a dynamic array of bytes, where byte is an alias for bytes 1, which is an array of 1 byte. The maximum bytes array is bytes 32 size, and you can see the example of it here, where I'm declaring the maximum available bytes array. And instead, as we saw in the example for integers, when we declared it like this, we got a huge number. In this case, if we return this variable, we will just get FFFFF 64 times. Strings is another very common data type. String literals are written with either double or single quotes. As with integer literals, their type can vary, but they are implicitly convertible to bytes type. Under the hood, strings are basically an arbitrary length byte array. Now let's have a look at this example. So let's copy the code and go to Remix IDE, open a new file and paste it right here. Now we need to select JavaScript virtual machine here as an environment and compile the contract. Okay, that was done successfully. Now let's have a look at what these functions do. The setString function just sets a new string variable, foo, and getString just returns that variable foo. I will not delve into much more detail into how this works. We will have a look at how functions work in an upcoming lessons. So let's set a new string by typing ABC. Don't forget to use double quotes or single quotes around it. And as we can see, if we retrieve a string, we retrieve ABC. Now let's, just for fun, let's have a look how much this transaction cost. It costs 42,826 gas. Now remember that a string is a bytes array under the hood. So if we set this string a lot larger, the bytes array will automatically be a lot larger. And remember that everything in the Ethereum virtual machine costs gas to execute, and memory takes gas as well. So the larger the memory, the larger the bytes array, the more gas it will take to execute. So let's set this string and let's see how much this transaction cost. And we can see that this transaction costs 70,693 gas. So that's a lot more than if we set a short string. Now let's have a look at addresses. Address is a special data type that holds a 20-byte value, which is the size of an Ethereum address. Address types also have members and serve as a base for all contracts. Address comes with type members, which are balance and transfer, and the balance makes it possible to query the balance of an address, and the transfer member makes it possible to send Ether in units of way to another address. Now let's have a look at this example. Copy the code, go to Remix IDE, paste the code, then select JavaScript virtual machine if it hasn't been done already, and let's deploy this contract. Now let's have a look briefly what this does. The getBalance function takes a parameter address of data type address, and it returns the balance of that address. So here we can see our account, which was used to deploy the contract. Let's copy the address using the clipboard, and let's copy the address here. Make sure to use the double quotes. Now if we get the balance in units of way, so that's almost 100 Ether. Now if we go to another account, copy the address, and go back to our previous original account, and query the balance, we get 100 Ether, which is correct. So you can see how this works. Now let's have a look at enums. Enums is just one way to create a user-defined type in Solidity where a keyword can be mapped to an integer value. It's better to explain enums by looking at this example. So copy the code again and go to Remix IDE, paste the code, and then compile this contract using JavaScript virtual machine. So we have a contract compiled and deployed, and now let's have a look at what this does. So here we have an enum of action choices, and it has 4 choices: go left, go right, go straight, and sit still. And then we have this choice which hasn't been declared yet, and then we have a default choice which we set as go straight. Now if we look at this function getDefaultChoice, it returns the default choice which we set as go straight, and the answer which we get is 2. So the default choice is integer 2. And in this case, the enum, since it's indexed from 0 to 1, go straight indeed does refer to the index 2. Now we can set the choice by ourselves by using this function, for example, set sit still, and we set our choice to actionChoices.sitStill. If we do so, and then retrieve the choice, which hasn't been declared yet. And here we use this function getChoice. We get the uint8 of 3. So sit still is at index 3 in action choices enum, and this is what it is. So that's how enums work. They're really useful to make code more readable. So we had a look at all the value types that exist in Solidity. Now let's have a look at the reference types. Reference types are more complex types than value types because they do not always fit into 256 bits and thus have to be handled more carefully than value types. Since copying them can be quite expensive, we have to think about whether we want them to be stored in memory, which is not persisting, or storage, where the state variables are held. Before we look at the reference types in more detail, we need to have a look at the data locations that exist in Solidity, and that's memory and storage. Memory and storage are analogous to memory and hard drive storage in a computer. The contract can use any amount of memory as long as it pays for it during execution of its code. But when execution stops, the entire content of the memory is wiped, and the next execution will start fresh. The storage, on the other hand, is persisted into the blockchain itself, so the next time the contract executes some code, it has access to all the data it previously stored into its storage area. So be careful about which one you use. If you do not specify whether memory or storage should be used, Solidity by default will use storage for structs and arrays even when they are declared as local function variables. This is because arrays and structs are complex data structures and could be of variable length. This is ideal for storage as it operates as a key value data structure which can always be expanded. On the other hand, memory dedicates a fixed length space in memory and thus is less expensive to use, but it cannot be resized. This is ideal for simpler data types such as integers, booleans, and so on. Remember, as a rule of thumb, state variables are always in storage, function arguments are always in memory, and local variables are always in reference storage. Arrays is the first reference type we will have a look at. Creating new arrays is possible with using keyword new. So let's have a look at how this works. Copy the code, make a new file, paste the code, make sure that we are on JavaScript virtual machine, and let's compile and deploy this code. So now once that's compiled, let's briefly have a look at this new R function. This takes an argument len of data type uint, and it declares a new array in memory, first of uint data type and of length 7, and then a new bytes array of whatever length we give to this function. So let's try to do that by giving it a length of 5. So here we go. Now once that's done, we have two new arrays. The first array, A array, is of length 7, and B array is of length len. So now it's possible to put the 6th element in array A to a value of 8. However, since the array B is only of length 5, if we did this B6 equals 8, that would be invalid. So anyway, this is in short detail how arrays work. Let's have a look at structs. Structs is simply a way to define new data types. Let's have a look at this short example, where we are declaring a new struct, book. What this will allow us to do is to define new variables of data type book, or make an array of books, where each instance in an array is a book, and each one of these would contain a title, an author, and cost. What this allows to do is to make the code more readable and maintainable, and also a lot clearer in most cases. Mappings is the last reference type we will have a look at. Mappings can be seen as hash tables which are virtually initialized such that every possible key exists and is mapped to a value whose byte representation is all zeros by default, but once initialized, it becomes equal to the newly set value. Mappings are only allowed for state variables or as storage reference types in internal functions. Now let's have a look at how mappings work by copying this code, going to Remix IDE, making a new file, making sure that we are on JavaScript virtual machine as always, and then let's deploy this contract. Now let's have a look at what this does. So at the top we have a mapping from address to uint. So basically the key is going to be an address of some wallet, Ethereum wallet, and uint is going to be the value of what will get returned. And this mapping is called balances mapping. So this is really similar to dictionaries in Python or JSON objects or just any kind of objects in JavaScript, for example. Now this function, update, takes a parameter new balance and then it sets the balance of whoever called this function, so that's message.sender. It sets the balance of this sender to the new balance that we set. And in the getBalance function, we retrieve the balance of whoever called this function. So let's say if we are on our default Ethereum wallet and we set the balance to 10 and we retrieve it, we get the balance of 10. If we go to another account and we select 42 and we update the balance and then we retrieve the balance, we get 42. And then if we come back to our previous account and we get the balance, we get 10 again. So this is how mapping works in short detail. I hope you enjoyed this lesson. If, of course, all the explanations are not in full detail, so if you want to read more about it, I would recommend going to official Solidity documentation, the types section, and have a read more about it here. I'll see you next.